Morning, students. Today we will solve the bar problem. These are the FEM problems which are fixed question in your exams. Okay. So what data is given? Young's modulus is given, that is 2.1 into 10 raised to 5, and Poisson's ratio is 0.3. Okay. And one side it is fixed, another side force is applied, and it is of 300 mm length. Okay. And diameter is given of 50 mm. So whenever bar problem is given, so you have to first calculate the area, because area directly is not given. So use the formula pi by 4 into d square. So put the value of diameter and find the area, that is 1963.5 mm square is the answer. Okay. So this is the bar problem. It is a fixed question. Okay. So let us start in the Ansys. So whenever you open, first go to file, clear start new, do not read file. Okay. And say yes. Then go to differences, structural, okay. Then preprocessor, element type, add edit delete, add. Now which problem we are solving? Bar problem. So when we are solving bar problem, we should use link 2d star 1. Link 2d star 1. Then say okay. So link has been created, then say close. Then finish this element. Then this is a bar problem where we have calculated area. So we have to give the real constant. Real constant means nothing but area. So we have to give the real constant. Add edit delete. Add. Okay. So real constant number 1. Then cross sectional area. How much you got the answer of area? 1963.5. In the last box, you know that should be empty only. Then say okay. So area is given now, set 1. Okay. So only one bar is there, so only one area. Then say close and finish it. Then go to material properties, material models, structural, linear, elastic, isotropic. Then put the value of Young's modulus 2.135. Then Poisson's ratio is 0.3. Then say okay. Close this. Close this. Then section. So we should not use section because it is a bar problem. So don't use section in the bar problem. So directly we will go to modeling. In modeling, what you have to do? You have to create 2 points, and in between you have to create element. So we are using bar problem, means we should use nodes to create points, and in between you have to create the element. So go to nodes in active CS. So here, how many nodes are there? 2 nodes are there, 1 and 2. First node is at 0. Second node is at distance of 300 mm. So let us put node number 1 at what distance? 0. Then say apply. Then second node is at a distance of 300. Then say okay. Our 2 nodes have been created. So close this. And next, meshing. We should not do meshing, but still we have to create element, right? So nodes we have created. Now we will create element. Once you go to element, you go to element attribute. In element attribute, real constant set number 1. It should be 1. Okay. We check that whether it is 1. We say okay. Then go to auto numbered, through nodes. Then select node 1 and node 2. Then say okay. The element has been created. Then go minimize through and close this. So now we have created the point also and element also. Then next option is meshing. So we are not doing any meshing here because it is a bar problem. So meshing we do only in the beam problems. Okay. Let's close here. Then go to directly solution. Then in solution, what you have to do? Go to solution. Then define loads and apply structural displacement. What you have to do? Go to solution, define loads, apply structural. Okay. So now what we have to do? This side it is fixed, so we should use the option of displacement and we have to fix this side. And this side there is a force, so we have to use the option of force and we have to apply the force on the right side. So let us do that. So first we have to fix, then use displacement, and what you have used here, nodes or 3 points. You have used nodes. So select on nodes and select this first node and say OK. And here you select all degrees of freedom, say OK. So this has been fixed now. And then this side, that is on node 2, you have to apply the force. So for that, first minimize the displacement, then go to force, then in the force you go to on nodes. Abhi, you have to select node number 2 because the force is on the node 2. Then you say OK, then the force is in effect direction, that to positive. The effect 1500, say OK. Now force has been applied. Then minimize this. So once you fix and you apply the force, then what you have to do? You have to solve it. So in solution only, in blue color there is option called solve. Go to solve and say current ls and say OK. So solution is done. Then close this. Then you have to go to general post processor. Here you have to see the results. So for that, what you have to do? First, when you go to general post processor, you should always first go to element table. In element table, you should go to define table. Then say add. Then come down by sequence ls and ls1. Then say OK. Then close. Minimize this. Minimize this. Now, here what you have to calculate? You have to calculate the displacement. Then you have to calculate the stress, and then you have to calculate the reaction. So we need these three things. So you have to see where are these three things. Okay. What you have to do? Once you go to element table, define table, ls1, if you finish that, what you have to do? Directly go to plot result, then go to contour plot, then go to element table and say OK. So here you see this dmx, this is displacement, and these are the stress, that is smn and smx. So these two values are the stresses and dmx is the displacement. Okay, so this one you have to take the screenshot and take the printout. Now here only below the plot result के नीचे ही इधर देखो list result. So many results are there. Okay, in that what we want first is displacement. Okay, so displacement हमको क्या क्या मिला? Q1 that is 0, Q2 is 1.091 into 10 raised to minus 3. तो ये अपने को कैलकुलेट करने के बाद इतना मिला. स्ट्रेस कितना मिला? 0.7639. रिएक्शन कितना है? -1500. So this much we have got by doing analytical calculations. Okay. अभी क्या करना है? First displacement के लिए you have to go to nodal solution. Displacement मतलब क्या? Nodal solution. Remember, nodal solution. This यहाँ पे आपको डिस्प्लेसमेंट मिलेगा नोडल सोल्यूशन. तो गो टू नोडल सोल्यूशन, then say DOF solution, displacement vector sum, say okay. So this is your displacement. Now here see node 1, that is this is your zero value, that is q1 हमारा 0 है, so we got 0. q2 it is 0.1091 e minus 02. So this whatever value you got, this value you have to write it here. So this is your Ansys result, and this is what you have calculated. So these are both of the same one. So you have validated it. So ये हमारा displacement है. Remember this value. So here also this value has been given. Here also it is given. Here also the value has been given. One and the same. So better you see this value and you have to write it in the table. So this table carries marks. If you draw this table, write the answer, then only you are, it is considered as you have solved. And इसको कॉपी करके वर्ड में पेस्ट करने का, दैट यू नो ओनली. ओके, नेक्स्ट वी क्लोज दिस. नेक्स्ट अपने को क्या चाहिए, वी नीड स्ट्रेस. स्ट्रेस कहाँ मिलेगा अपने को, स्ट्रेस यहाँ पे रहेगा, दैट इज एलिमेंट टेबल डेटा. ठीक है, element table data means stress. So open this and select your ls1, then say okay. ये हो गया हमारा stress. So this is our value of stress, that is 0.76394. So this value you have to write here. Here you have to write. So calculation value or Ansys का value, both are exactly same. So 100% whatever you did is correct. Okay. So this is your stress value. So remember, stress is nothing but element table data में तो stress का value मिलेगा. Next is reaction. Reaction देखो इधर ही है. Reaction solution. So this will give you the reaction. Where you select all items. Say okay. So this is 1500 meter. So this is your reaction. So this value you have to write it here. तो ये हो गया आपका रिएक्शन. तो याद रखो डिस्प्लेसमेंट कहाँ पे मिलेगा आपको, डिस्प्लेसमेंट यू विल गेट इट इन नोडल सॉल्यूशन. स्ट्रेस you will get it in element table data. Next, reaction you will get it in reaction solution. So these three things you have to remove and see what is the answer, and that you have to write it in this table, and you have to same thing you have to copy it in the word file. Okay, remember nodal solution, element table data, and reaction solution. So this much you have to do and save that word file and write the answer in the table. It is very important to draw the table and write the answer. Then only you have done completely correct. Okay. So same way you have to do for all the problems. Okay. Thank you.